Hello everyone, my name is Jia, and I'm from Microsoft advertising team. I'm working on the advertising product ads. I have been working in Microsoft for 3.5 years after I graduated from University of Southern California. And my work is mainly on advertising, shopping, and image understanding. So it's all of my interest. So I always feel very lucky to work on the things I really like. Yeah. So today I'm very happy to be here to share with you what I'm doing here in Microsoft. So the topic today is about shop what you see. It's a visual product recognition on Bing Image, Bing Shop, and mobile app. So yeah, to start, so in many cases, yeah, an image is worth 1,000 words if you would like to describe a product. If, for example, if this is a pair of shoes, I want to search and buy it online. The traditional way of searching is kind of you can open some search engine web page and you type the text to describe and name the products. Like this one, we can type brown cross-lacing ankle shoes. So like both Bing and Google can return some results for you to shop. But look at the results. The results may be very perfect for the query, brown cross-lacing ankle shoes, ankle boots. But it's not the one I'm looking for. It's because sometimes it's hard for users to describe all the product attributes, like the heels, the style, the shape. So why don't we use image itself? So our project is to provide a solution so that you can search, you can shop with visual search. It is intelligent product recognition and search. Yeah, for example, this example, we can return exactly the same or the similar products. Yeah. Image worth a lot, thousands of words to describe the product. But if we cannot do the user experience right, we may lose the user. So our first target is to understand what the user looking for, what are they want to search. And if we show ads for users, we show the ads of their interest. We see, for example, if we show ads, if there is interest, then there will be a click. That means we did a good job. If not, maybe we can show other options, like maybe other similar look products, or maybe product from different sellers, different price, different brand. Or if you are searching for fashion products, we can recommend some fashion mix, some products may go well with the product you're looking for. So here is an example. It's a blonde, it's a blue dress, which one I really like. So I searched it on the Bing image search detail page. You can see with one eye click on the blue hot pot, the one is detected by the object detector. When I click the hot pot, it will trigger the VPR API, and it returns several visually similar ads. The all blue maxi dress, but I didn't input any text to describe what I want. This one is also interesting. It's a Kate Spade handbag, which one I also like. So I look at it on the Bing shop here, and our API can tell you other styles you may like. So which means you can look at other styles from different sellers, different brands, but with a similar look, which is also black handbag, but with some dot patterns. But it's, yeah, a lot of different options. This one is women's top. You show this top, you search for this top on the ad detail page. We show some other style you may like, and also we give recommendations. Maybe this top can go well with these pants. Yeah, so it's fun applications. And we developed this VPR as API, so we also developed a mobile app to demonstrate how we can do. The first demo, yeah, here goes the demo. It shows they launched the user's camera to capture an product This is a backpack, and we crop in the backpack. Here we show some backpacks product ads. Backpacks, but may have different price, different seller. And another one is similar app, but we can use users' local photo. Like this one is a dining room photo. We crop into, maybe you are interested in this data dining table set. Yeah, here is a similar product ads we can serve. Yeah, click on the ads. It will lead you to the product page for purchase. Yeah, all of those are some very fun applications we already integrated in the Bing's production. And this VPR is available. So which means if you are a retail store owner or you are from some retail company, which is very great that we can very happy to work with you to let you leverage our API, which means you can take your image content and call our VPR API, we can return some ads. This is a win-win solution. Because with this user engagement, it always gives very good user experience. So let's go to the tech stack. For example, this pair of shoes, what can you see from this product? For us, it's quite straightforward. It's shoes. And the brand is Nike because there is a Nike logo and also some Nike brand name over there. And the color is black and white, and it's running shoes. And this pair of shoes is, I think it's for unisex, more and or women, and definitely not for kids for me. Yeah, so our target is to train the deep learning model to understand this kind of information as a user can do. So the main problem we are facing is first, what's our product? We trained the product recognition and the classification model to solve this problem, and then to select visually similar product ads, we have the nearest neighborhood graph search technology, and we have relevance model to have the quality control to filter out less relevant ads, and then to rank the top matching as top, we have ranking models. This is a VPR system architecture. So start from the raw image, then it's followed by a product classification. Here is a deep learning inference system. We encode the raw image pixels to 1024 dimension vectors, and then we use the rich CDSM model to further encode this vector to 64 dimension. And then we do distributed nearest neighborhood graph search to do the ad retrieval. Then it's a precision layer, which is a relevance model to fill out the bad ads. And then we have, after this distributed selection, we will have a re-rank aggregator to use the visual similarity for ranking to select the top ones, which will show to users. Yeah, before we go to the model training, first we look at how we collect data. First, the important one is the metadata. Product ads has metadata. Every product ads is comprised of a product image like this. There is an image, and also there's a title and the seller and price information. And sometimes the ads also come with ads description, which can include a lot of product attributes like color, brand, style, gender, this kind of information. This is very important for us. And the second one is ads with clicks. When the ads with user clicks, which means the product is very related to user's query. So we kind of leverage the metadata and the user clicks to depict the products in the image. So this add metadata and the user clicks, we can treat as labels for the product in the image. The second data we are collecting from the defect measurement. This is to evaluate how well an ads is matched to the product image. We give 5 levels like bad, fair, good, excellent, and perfect. Yeah, so we invite the judges to help us to label whether the ads and the image match very well. And for example, remember the Kate Spade black headband as example I gave. If we can return an ad, it's also Kate Spade and its color black is the headband. I think it's a good example. If they are also with some white dot pattern, then it is an excellent match. Go further, if the ads image is ideal product image with clean background and the quality is very high, we label it as a perfect pair. So this kind of data is used to train our relevance model and for the performance evaluation. We train a lot of models, and I will give examples for several ones here. One is the GoogleNet model for image classification. GoogleNet model is not new to us. It is also known as the Inception version 1. It's 2014 winner in the ImageNet large-scale version recognition competition, and we use this because it has 22 layers, which is not too deep, so the computation is not very time-consuming for us for the online ad serving. So we take the last hidden layer of the 1024 dimension as the image feature vector. However, this is 1000 dimension is still too big. So the other model is a rich CDS model. We use it to reduce the image feature vector space from 1022 to 64. Like here, we leverage the text as query to collect the information and add metadata to guide this feature dimension reduction. So when, as I say, when a user click on an product ads, we can say the product ads metadata and the query is relevant to the image product. So we feed the table the CDS model like this. On the right side, you can see we use 2 convolutional network for the text and 2 fully connected layers for the image from 1024 to 64. So this model and this treat model we used to further encode the feature vector to a very low feature space. And we conduct the nearest neighborhood search on this 64 dimension, which is very efficient. Even with search image, we can return ads with a similar time when we're doing text retrieval, which is very convenient and very efficient. Another model we use is a relevance model. Since after NGS, the ad retrieval, there are many visually similar ads returned. So not all of them are good enough. So we need a relevance model to filter out the bad ones. This model is a fast rank regression model, and it is a boosting decision tree. So the most important feature for us is product type match, and semantic similarity, visual similarity, and image quality. With this relevance model, we improved our VPR performance, very significantly. Here is some results example we test on the user capture image. It's a very challenging test set because, for example, some image has a very noisy background and the target project are cropped out. The first column is the original image. The second one is the cropped products. And and on the right side, the 5 column as we can return. It's suits, pens, sunglasses, tights, and handbags. However, we can do very well on the fashion categories like clothing, shoes, jewelry, and watch, and home furnishing. But not other categories we can do well. And there are some challenges we are still facing, like sometimes the products are cropped, but they are partially cropped, and the product is shot with slant. Shooting angle and with complex background, which makes the object detection very challenging. And for example, here the third example gives one a woman having the earring. When we crop the earring, it's kind of object is small and the object is blurry. It's hard for computer to get all the details. Even for me, it's hard to see the details. So this is very challenging. And another example is like this is a woman with a T-shirt, but after we crop the product, like we get only the T-shirt, we kind of lose the gender information. So the VPR return ads is for women, for men T-shirt. It's definitely not right. And for some applications like women, people are searching for like beauty products. They do care very much about their brand, the brand. So we can show ads which look similar but different brand. So for this one, the brand is very important. We are thinking about using the OCR technology to extract the words information, maybe a very good signal for us to understand the brand. Yeah, that's all about the work. So we provide a solution for the visual search. And we developed a deep learning models and a scalable system to detect, recognize, and understand the user input image to match with the product ads. And there are still a lot of challenges we are facing. So it's still not perfect. We are working on that. But the shopping by image is a very powerful way that in the next 5 years, if you are like doing shopping online, yeah, definitely it's a very good way. Yeah. Yeah, that's all about my talk. Yeah, if you have questions, yeah, please feel free to ask. Thanks.